GPS is wonderful. Without it, a whole bunch of us would be really lost a whole bunch of the time. It's the global positioning system. Airplanes use it, ships use it, mountain climbers use it, even pizza delivery guys use it. Hey Siri, what's the deal with GPS? This here is a GPS receiver. Oh, and also my phone. This is the part of the system that tells me where I am, currently in the middle of nowhere, and where to go, hopefully somewhere with a Starbucks. But this is only part of the system. It's called a receiver because it's receiving signals. That means that somewhere out there must be a transmitter that is sending out those signals. Or in this case, a lot of transmitters in space. This is the other part of the system. It's a network of 30 satellites that orbit the Earth in a kind of a grid. They're like an eye in the sky. Each satellite is about 20,000 kilometers high and orbits the Earth twice a day. Every one of those satellites is constantly sending out a signal. They're electromagnetic waves, just like radio and television signals, but at a different frequency. Those signals are what this receiver is receiving. But it's not just listening to one satellite. It's listening for as many as it can. In fact, at any point, it could be hearing from up to 8 or 9 of those satellites. See, the reason the satellites are arranged in this grid pattern is so that at any moment, no matter where you are on Earth, you will always be visible to at least 4 of them. Not that they're looking at you, though. They can't see. What I mean is, no matter where you are, you could draw a straight line from you to at least 4 different satellites. And that is the key to how this whole system works. Those signals from the satellite travel at a known speed. That would be the speed of light, 186,000 miles per second. Each signal has 2 bits of information. First, an insanely accurate timestamp that says exactly what time it left the satellite. And second, the satellite's exact location when the signal was sent. Since each satellite is a different distance from me and the receiver, that means that each signal will take a slightly different amount of time to reach me. Even at the speed of light, a signal coming from a closer satellite will get here before a signal coming from one that's further away. The receiver compares the timestamps from the incoming signals with the current time. By comparing those tiny time differences, the receiver can work out exactly how far it is from each satellite. So, if this phone knows exactly where each of the satellites are, it does, and if it knows exactly how far it is from each of the satellites, it does, it can calculate exactly where it is. So from 20,000 kilometers, those satellites and my little iPhone can pinpoint my location to within 3 meters. So, Siri, where is that Starbucks? But this is only part of the system. That was just me. Other part of the system. And I lost it. Lost a whole bunch of the time. Blank. Okay. Here we go again. In this case, there's a lot of... I'm sorry, I screwed that up again.